Hi, I'm Alex Pault, and today we're going to talk about artificial intelligence and embedded electronic engineering with Houman Zarrinkoub. He is the senior product manager or a senior product manager. He has a lot of roles, I understand, at MathWorks, and we're going to talk about that. Isn't that right, Houman? How's
Yeah,
it
thank
going?
you very
You
much
know?
for inviting me. Yes, I have been in this position at MathWorks for about 23 years, and I've done multiple functions and wore multiple hats. But we are talking about AI, which is an emerging field these days in engineering. Yes.
Well, but the interesting thing about it is it's not like there's some school of AI out there that the young kids are getting and the us older people can't get into it. It's a brand new field. As long as you are able to run with it, we're literally making it up as we go along.
It's true, although it has its foundations in the curriculum of electrical engineering for a long time. I remember in my PhD, I took the pattern recognition class, which is essentially the foundation for AI. And pattern recognition is the way we humans understand the world around us. So it has a long history, but in this formal state, absolutely is new and exciting, and we have to get with it.
It comes down to the tools to make the tools, as it were, right? The tools to validate the tools.
Yes.
The lines on the ruler have to be the exact length apart on everyone's rulers. Once you create an AI, how the AI is validated and certified, that you're going to probably need another AI to do the research on the other AIs just for. So then you start getting into a layered situation. You got the device AI, the company AI, the regulatory body AI.
It's absolutely true, my friend. So the way I see it is, that humans and even animals have instinctive behavior versus learned behavior. So instinctive is hardwired, right? Learned, the behavior is not hardwired, but you have given this chance to program yourself. And if you program yourself, somebody has to program the programmer, and so on and so forth. Exactly what you said. Learn behavior in its multiple iterations and levels. It's exciting.
It is very exciting. So, having said that, and MathWorks is one of those companies that makes the tools that makes the tools. What is your perspective on that whole landscape of evolving artificial intelligence and machine learning?
I thought about this for your being with you, and the first thing that came to my mind is necessity. I mean, there is no chance for the future civilization that we are building to not use this notion of AI embedded in our lives. And if you want to justify it in terms of engineering background and justification, is the notion of complexity and the notion of expectation. The expectation has risen so much, and the complexity of different things that make the expectation reality, there's so many of these parameters and complexity. The old rule-based, human-defined, formulas doesn't work. So necessity is the mother of invention.
Makes a lot of sense there, Human. So then, at a design level and all, I was going to ask you how MathWorks is approaching it, but I understand you have a presentation you can show us.
I put together some slides for you to go over the concepts that are useful for this talk, and then afterwards we come and elaborate if you like on this
Let's
topic.
do that.
That's great. So let me share with you some slides that I put together. I titled AI-based sensor design and 5G, 6G wireless connectivity. That's the first thing that I want to emphasize. The increased wireless connectivity that we see is happening. The expectations have risen, meaning that no matter where you are in the world, you want the users to connect to internet and be essentially plugged in. You can do it in urban areas, in indoor areas with Wi-Fi technology. You can have it in the large underwater space, satellite, and so on. So this is called modalities that we want, no matter where we are, have ubiquitous connectivity. And the number of users has increased, meaning that Not only we have our cell phones and talking to each other using our devices, these automated driving systems, these smart cars,
ADAS
they need to talk to each other and talk to the infrastructure, talk to the red light and green light and so on and so forth. And more devices and more sources of information are coming. Now that you know that there's exploding user base and the exploding number of modalities of connecting these people, let's talk about complexity and expectation. Prior to this emergence of AI, the expectation was that some wireless communication system is set in base stations, in Wi-Fi, and so on, and there's an average performance that is accepted, is given. But more and more, we want every smart device and us and anybody else to be essentially embedded in an environment where the system knows where we are, what we are doing, and does the best to give us the best quality of service. That's where the notion of wireless sensors and actors come in. What do I mean by wireless sensors and actors? So from the perspective of a guy using the wireless network, our cell phones, and there are sensors in that, our location, GPS location, and all kinds of environment. From the environment, there are sensors, right? And this sensory information goes to some central place, get essentially processed, right? And these different kind of sensors, but for a car, radar and LiDAR and this and that, they gets processed and then actions taken, and actions could be to essentially change the way the wireless communication sends information to you, the bandwidth, the modulation, the coding, all of that. So as you change your real-time situation, the wireless system using sensors and actors senses your changing situation and responds to it. This is the foundation of the future wireless connectivity. Expectation has risen to have not only ubiquitous where you are, in every place you are, custom design the solution for you. What is artificial intelligence role in this? So we have had a lot of success with artificial intelligence in other areas, in images, in voice, and other areas, this generative AI that people use and large language models. Now it's coming into wireless communication, and you want to improve performance based on data. Those sensor and so on provides data. You want to improve performance, learn. And when you learn using AI, the complexity can be handled because AI is essentially ready for any complexity. Essentially, you facilitate joint optimization of network and devices. As you move, as you change, as the car moves and changes, there is feedback. Those sensors provide feedback, and you can respond to it and optimize the performance. This is the things that AI provides that the old-fashioned stuff cannot do. And I want to capture your attention to this particular diagram. This diagram is essentially what reinforcement learning calls an agent-based learning, but this could be essentially a diagram of a nervous system. The agent is the brain, is a central processing part, right? It has observations coming into it, that's the sensors, from the environment. And there is some kind of a policy, some kind of a rule that AI brain, right? That based on observation does something. So maybe that something is the best, not the best, and so on. Actions is taken. That's called actions and actors. And the action goes to the environment, and another observation comes, and based on what the action does to environment, we keep learning and improving the next action, the next policy. That is beautiful because it shows how reinforcement learning, how AI is learning not based on a specific hardwired pattern, but based on a pattern of behavior that evolves with time as we keep observing and keep acting. And that's the way a baby learns how to talk and walk, and every animal who is capable of learning does things. So we are bringing the philosophy of learning, non-instinctive learning, into essentially engineering and wireless communication. So you want to bring that learning and AI-driven stuff into wireless communication. What are the 4 steps? There are steps. First, you have to have a lot of good data. AI will not work with data. AI is a learning paradigm. If you don't have enough data, your solutions are suboptimal, and they will fail when they face different environments for which you don't have any data. So data is important. Then you need to have that brain, that model, that policy, that rule that takes the data and creates a recipe for action. Then you have to have these things continuously tested and simulated. And that's where the notion of digital twin comes in. Digital twin is the simulated version of reality in your computer. So you have a base station and a simulated complete specification of the base station. You have autonomous car and a simulated, completely computerized version of the car. That's what simulation and testing. And then after everything is done and tested and simulated, you want to deploy that final algorithm, the optimal algorithm, into the device, but also leave it to get data and be updated. That's the 4-step process of any AI-driven wireless system design that we see our customers do. And what is the application to 5G, 5G advanced, 6G? We live in a 5G era. 6G era is about 5 to 10 years away. But still in the 5G era, you see the cellular services and the connected cars and the satellite connectivity is being discussed. And not only UAVs for purpose of delivering different things. These are all converging into that AI-driven, they call it AI native paradigm. So to summarize, the operation of sensor networks can really define situational awareness. So you have raised expectation. You want the system that gives us wireless service to know where we are, to know what we are doing. That's why we have to be localized and positioned. Where are you? What are you doing? So that is the reason why sensors are very important. And then after you have information from sensors, 5G and 6G and Wi-Fi are evolving to use the sensor information, to have policies updated, to provide you the best wireless service using the best spectrum, the best modulation, the best all kinds of parameters that you need. These parameters are huge amount of them. And for that, you have to rely on AI and MATLAB tools in RF propagation, AI, ray tracing, reinforcement learning. We have libraries for all these different domains of engineering that converge to give you a real design of a real AI system.
Very cool. Houman, that was very informative. And I think what it also does is that it emphasizes some of the more positive aspects of AI. You could almost say it's a pure application, as it, you're not asking it for interpretation. You're not asking it to create a piece of art or to you're using it for what it's best suited for, managing complex systems that are running within a certain parameter set. So they're able to become, in the old sense, specialists, know everything about very little, and to properly address the application.
Prior to AI, my friend, the human engineer was in charge of gathering information, solving it in our brain, and have a solution which is static. So all we are saying is human engineer lets the information that has come to him go to a system and teach it how to gradually think. Not in a human sense yet, it's pattern recognition and basic thinking. But then instead of a fixed static solution, updated, reinforced, and dynamic solution. And that's the exact next step. Nothing horrendously, they say evil is going on here. Everything
Right.
is benign and nice in that
Well,
sense.
but not only that. I mean, the whole aspect. The reason what I was saying within a set of parameters is when you're talking about wireless networks, it's incredibly complex. But in another sense, it's pretty straightforward.
It's
So as long
contained.
as yeah, and so the AI can stay within the lines, as it were, and learn as much as possible about what's going on within that network. And I do believe eventually you're going to have an AI in everything that's smart.
I
You
have
know,
the same feeling. If anything
or at least
has,
an ML subroutine.
yes, anything that has today chips in it could be a AI chip in the future. Yes, it seems that's possible. Absolutely.
Or at least maybe a very focused machine learning algorithm for whatever the vertical application is. Because if it's a video game controller, it doesn't necessarily have to have a full blown AI, but it could have a ML, a machine learning algorithm to better interpret the user's movements and optimize their operation of the device, for example, within that realm of gesture capture.
And I just want to capture attention to one thing. Do you remember old times when we were going to school, me and you? Everything was on desktop computers, this program, that program. Lately, everything's on the cloud, right? And our computers essentially connect to the internet and grab the stuff. The same thing can happen for AI. It sits on the cloud. We provide sensors, information to that wonderful contained, as you said, wireless system, and the thinking is done there, and we get the actions, and so it's the same way that centralization can help. It sounds a little scary, but it can be contained and made. It can also happen in this case. AI systems that are local to your environment, or AI systems on the cloud, which have the benefit of gathering a lot of information and therefore provide a more optimal solution. Whereas if you're relying on your own desktop, maybe the solution is more local solution.
Agree completely. So, do you have any final thoughts or things that you wanted to bring up before we let you go today?
It's very exciting times to be in here. I think I was telling my friends 10 years ago, if you don't know the foundation of this new standards, 4G, 5G, which is OFDM based frequency domain, you will not be a successful engineer and won't have a job soon. I'm telling my friends, my son, my daughter, if you don't know about AI, you may not have a fruitful career. So get yourself on the AI. It's nothing that's going to hurt you. It's all good. It's all nice. And see how we are teaching our computers to help us think, help us grow together. So, and MathWorks, we have so many products and so many workflows and so many things to help you gradually ramp up your knowledge and your expertise to implement AI systems and networks.
Very cool. Thank you so much, Houman. I really appreciate you taking the time to talk to us about all of this. And if we get any questions from the audience, we'll make sure to forward them to you.